Hello there. I welcome you all again to another beautiful day to learn. Thank you for all the likes. I appreciate them all. Thank you for all the subscription. You subscribe. Just keep subscribing. Click on that subscribe button. Thank you for following us, for clicking on that follow button. Thank you for even the question. Somebody sent in a question that he wants clarity on a particular maths question. And thank God I was able to clear the air. And the person gave me a thumbs up. Thank you for everything. Please keep sharing our videos. Ensure that this video gets to the four corners of this world. Let's raise academic champions. We can do that. Now today, physics. We're looking at this topic called waves. I believe you all know what waves are. If you take a stone and you cast a stone into water, what do you notice? You see a wave being made, is it not? By the stone, that external force thrown into water. That is a disturbance. So if you ask, what is a wave? Remember, write this down. A wave is a disturbance that travels through a medium and transfers energy from one point to the other without causing any permanent displacement of the medium itself. I take that again. I said a wave is a disturbance that travels through a medium and transfers energy from one point to the other without causing any permanent displacement of the medium itself. I hope you got that. We have different kinds of waves. Now, I pick up some books, some textbooks. I see them. They say we have two classes of wave. This one we say mechanical wave, and this one we say electromagnetic wave. Some will say we have transverse wave and we have longitudinal wave. Now, please, let me clear the air. Look at this. We have two broad classifications of wave. A wave can be classified, one, based on whether a material medium is needed for propagation or not. Now, in that class, we have two kinds of waves, and that is the mechanical wave and the electromagnetic wave. A mechanical wave is that kind of wave that will require a material medium for propagation, just like a water wave, the one I cited from the beginning. You remember? So it needs a material medium. For you to see that wave in water, you must see something cast into water. Isn't that true? Now that's a mechanical wave. It needs a material medium for propagation. An electromagnetic wave does not require a material medium for propagation. Look at the sun reaches us without what? Any material medium. Now remember that we have different kinds of electromagnetic waves. Now I'm going to help you classify this. Please, just a tiny secret I'm going to let out to you now. Write this down. We have R me volts G. R me volts G. So this is the arrangements. This is my radio waves. This is my microwave. This is my infrared. This is what? My visible light or violet rays. This is my ultraviolet rays. This is my X-rays, and this is my what? Gamma rays. So from radio wave down to gamma ray, of course you know that gamma is more penetrating. So we have increase in frequency. The reverse is what? Increasing wavelength. So just take notes. Remember this. R me volts G. This is the arrangement for electromagnetic waves. So it does not require a material medium for what? For propagation. Now, the second class of wave is based on the direction of travel of the wave to the direction of propagation of the particle. In that sense, we have the transverse and we have the longitudinal. Now, I will make a video that will cover these different aspects. Let's come back to this question. Now, we have this question. Some students often find this very difficult, answering a question on a progressive wave. But I'm going to give you a simple way to understand this. Look at this. This is my wave front. There are two major forms of wave, but I'm going to work with the one that has this. That is a wave that starts from a displacement away from the origin. Of course, this height is my amplitude. You know that when we move this way, this is one wavelength. This is half. So what I've drawn here is actually 1.5 wavelengths. Now, if I want to write the equation for this, it will be A sine theta plus or minus what? Rho. A sine theta plus or minus rho. Now the reason you have two angles is because we have the angle made by what? By the origin, and we have the angle made by what? The wave traveling. So we have this. The plus and minus means that the wave can be moving to the right or what? Or to the left. Okay. Now remember that my theta is angular frequency times time. W means angular frequency. While my rho is what? Kx. So if I want to rewrite this, let's call this equation 1. So if I want to rewrite this with this, my y will become what? A sine Wt plus or minus what? Kx. Let's call this equation 2. But take note, my angular frequency is 2 pi f. My k, that constant k, is 2 pi over lambda. So if I rewrite this equation with this, that means this will become y equals to a sine, instead of writing Wt, that will be 2 pi ft plus or minus, instead of writing kx, that will be 2 pi x over what? Lambda. Equation 3. Of course, from here you can find as many equations as you can. We know that what? V equals to f lambda. So f equals to v over lambda. So I can rewrite this as y equals to a sine 2 pi. Instead of writing f, I'll write v over lambda t plus or minus 2 pi what? X over lambda. I can call this equation 4. You can just continue. What is common? 2 pi over lambda is common. A sine 2 pi over lambda Vt plus or minus what? X. Equation 5. In science, you can just keep discovering. You know what we do in science, aside observation and theories and laws, is what? Discovery. Discovery. Different people are discovering things today. Remember, sir, recently something was discovered in America. They called it americium. Something was discovered by a man called Lawrence, and they call the element what? Lawrencium. You can discover something. Maybe if the simplifier discovers something tomorrow, an element, what do you think we can call that? Please let me know a possible name, because I am into discovery now. Give me a possible name if I discover an element tomorrow. Let's see what that will be. Now, once you have been able to do this, the only thing that is left is look at the equation given to you. Which of this equation looks exactly like this equation given to you? Of course, you are right. And that is equation 2. So what I'm going to do is, I'm just going to take this off. The equation I need here is equation 2. And that equation 2 is what? Y equals to a sine Wt plus or minus what? Kx. And the question given to me is y equals to 0.5 sine 200x minus 10t. Can you see that this work is now very easy? What's the answer to question 1? Amplitude. Amplitude is just 0.5. You just need to what? Cross-check. A is 0.5 meter. Very easy. Wavelength. Where is my wavelength? The wavelength is under this. Remember, k is 2 pi over lambda. Remember, if you remember, k is 2 pi over wavelength. Isn't that true? What is my k? K is 10. So that will be 10 equals to 2 pi over lambda. Cross multiply, 10 lambda equals to 2 pi. So my lambda is just 2 pi over 10. 2 in 10, 5. That is pi over 5 meter. Please here, pi is not the regular 22 over 7. That is not pi, remember. Okay, let's go to 3. They say we should get frequency. Where do you have frequency? Remember, angular frequency, 2 pi f. Remember, 2 pi f. We're looking for this f. W here is 200. So 200 is 2 pi f. We're looking for f, so divide both sides by 2 pi. 2 pi cancels 2 pi. 2 in 200, 100. So my frequency is what? 100 over pi. Frequency is measured in hertz. Can you see how easy this is? The only thing you need to do is what? Remember this equation. And when you're given a question on progressive wave, look at which of the equation looks exactly like what is given to you. And you will solve this in less than 10 seconds. All right. Finally, my period. Remember, period is given as capital T. Period is just the inverse of what? Frequency. And what is my frequency? 100 over pi. So if you want this out, my period is just pi over 100 seconds. As easy as ABC. Can you see how easy physics is? Remember, I always keep to my promise. And I have made another promise that I'm going to discuss more on waves, because there are so many other aspects of waves. and I want you to be proficient when it comes to wave, so that when you're faced with any question, whatever it is, wherever it's coming from, you will know exactly what to do. Keep following us, and let's make you that academic champion. I am the Simplifier. Bye.